listen up, folks. Listen up. So this is not meant to be exhaustive. I just kind of jotted down some of the stuff that we've been doing. And we really haven't done a lot, but we've done a lot of things that seem the same, yet they're different. And so I want to just separate them out for you so that when I ask you to, say, draw a picture of something being charged by induction versus drawing a picture of something that's being charged by contact, that you've been reminded of the differences, okay? All right, so the first thing that we did, and I'm just going to call this static review. You can call it the static electricity review, all right? And the first thing we did was we talked about charges, so I'm going to just call it atoms slash charges, all right? Okay, atoms and charges. Oh, are we not ready to roll? Oh, the pencil is very important. Right there. Not the sharpest thing in the world, but it will write. All right, atoms and charges. And I started out by explaining to you that an atom has two different particles in the nucleus. I'm going to draw them again as filled in dots versus circles. And again, I'm going to remind you that this is the nucleus, and you'll notice that again, I'm shortening things up. All right, again, I've tried to impress on you that when you make your review notes, don't write everything out in full because you want your brain to see the words and, you know, remember what it means. And in that nucleus, I have two types of particles. And you know what? I think you guys know this. I could do the process of, could anyone tell me what the two particles are in the nucleus? But to be quick, I want to just review it, right? And so I'm just reviewing it with you. So hopefully you're thinking already what those two particles are. We have the protons. I'm just going to put a P. And they're positively charged. I'm going to put a little plus up there. And we have the neutrons, and they're neutral. And I'm going to put a little 0 up there. Okay. And I'm going to, and so that's pointing to the nucleus there. And I'm going to just put a big orbit around here. All right. And I'm going to put a couple of dots because this actually represents a helium atom, but don't worry about it. And these guys here in orbit are the electrons. Okay. All right. And remember, the electrons can be removed. They can be removed easily. All right, so electrons can be removed. Okay? All right. And the protons can't. I say that they're locked. They're locked in place. The position of the atoms locks them into place. Okay? So when we are doing something, then we're talking about the electrons being moved. All right? Are we keeping up? It's best to kind of keep up with me as I speak because you can hardly read the words half the time. So it's important that you're listening to what I'm writing because it's hard to see it. Oh, and I got a visitor? Do I have a visitor? I've got someone hovering around my door. Hello.
Hi, I'm just coming in for some enlightenment.
Good. Well, I'm making a recording. I'll share this with you and you can you can join in. All right. So remember, when we have our two possible charges, we're just doing a static electricity review in preparation for a quiz tomorrow. So when we have our two possible charges, right, I can have something with 4 pluses and maybe 4, actually we'll go with 1 negative, right? And that results in this being a positive charge. And if I have something with my 4 positives and say, what have I got? 1, 2, 3, 4, 5, 6, 7, doesn't matter, that's negative, right? Okay with that? We then did the law of charges. That might be the same lesson, so I'll just keep going. Law of charges, all right? And again, I could ask you guys, but this is a review, and we did this all week. You should be fine with it. Opposite charges attract, and like charges repel. 2 L's, repel? We'll just go with 1? Okay, thanks. Repel. That's why I need a sidekick right here to help me out. Like charges repel. Okay.
Now I don't.
All right. So the next thing we did there was charging. So I'm going to put this as number 2, and we'll call this charging. Charging objects. 1L. Nice. Charging objects. And this is where I want to separate out all of the stuff that we did, because we seem to be doing it, all the time, talking about the same thing. So charging objects, A or 1, I'm going to start with just A, and I'm going to say friction. Now remember, we did friction second, but I want to put it first. Friction means we're rubbing 2 objects together, right? Remember we did the lab, you guys rubbed a bazillion objects together? So friction. And again, I'm going to draw a picture of that, all right? And I'm going to go plus, 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 minus, 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 minus. We then had a rag or some sort, some kind of a thing that we're able to rub over it. Plus, 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 minus, 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 right? And then we rub that together. Notice my different arrows simply represents what happens next, okay? So here we're rubbing this back and forth. We could even put it like that for our picture, rub it back and forth. All right? And in the end, we end up with the rag being 1 charge and whatever we were rubbing being the opposite charge. And it doesn't really matter. I'll go plus, 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 and we'll only have 2 minuses on this one. And then plus, 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 plus. And now we'll have our 4 plus 2, 1, 2, 3, 4, 5, 6. Okay? And that's going to result in this being negative and this being positive. Okay? Does that make sense? The key to this, or something that I want you to notice, is we start with 2 neutral objects, all right? And we result in opposite charges. So when we rub 2 objects together, we end up with 2 oppositely charged objects. And again, hopefully that makes sense to you. Hopefully this is all like, well, sure, Mr. Sanders, of course it does. So we have 2 oppositely charged objects, 2 opposite charges. Okay? All right? Which is why when you say take off your sweater, right, and the sweater rubs up against your hair, what does your hair want to do with respect to the sweater? But when you bring your sweater close, what do they want to do? What do they want to do? They want to attract. And why would they want to attract each other? Yep, Jess? Because they're opposite charges, right? So you end up with 2 different charges. Okay, so that's friction. Now that we've got a charged object, let's talk about transferring by contact. Oh, how am I going to spell? I'll be fine. B. No, I won't. B, I'm going to talk about contact. And you know what? Back when I taught this years ago, I used to just call it contact, touching 2 things together. But the new textbook says, well, friction is by contact because they've got to be in contact with each other. Okay, I get that. So our textbook liked conduction. Conduction. All right? Oh, no, don't worry. Don't worry. In this case, we are transferring charge. Transfer of charge. Okay? Now I'm just going to do a couple of examples here. What if I have something that is negative? All right? 1, 2, 3, 4. And I'm going to go with 1, 2, 3, 4, 5, 6, 7, 8. All right? And I'm going to keep it even because we don't want any fractions, but we could have fractions. Wouldn't be breaking any rules. So this is -4, something that is neutral. 1, 2, 3, 4. 1, 2, 3, 4. This is neutral. I'll put neut 0. All right? Neutral. We're okay with neutral? Jess, you don't like neut for neutral? Okay. And now I'm going to bring them and I'm going to have them touch. I'm simply going to draw a line as if we put a wire between them, like grounding, except I've connected them with a wire, something that is conductive, that electrons will go through. Well, I think we know these electrons will repel over to this so that they become nice and balanced. So we will get electrons to move. And in the end, 1, 2, 3, 4. 1, 2, 3, 4. How many will I have on each? Anybody have that figured out? Jess, what do you got? 6? Because what have I got in total? I got 8 and 4, which is 12, 6. I like that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Which means my charges become -2 and -2. Remember the other way we did that? -2 and -2. Remember we did total -4 plus 0. That means -4 is the total. And then we've got to divide it by 2 afterwards. -4 divided by 2, there's -2 on each. Okay? Does that look familiar? What I want to remind you, though, of this is for conduction, I started with a neutral and a negative, and what did I end up with in the end? Remember friction, I started with 2 neutral and ended up with a positive and a negative. In this case, I ended up with a neutral. I have a neutral and a negative to start with. What do I have at the end? Yep, Jack? How many negatives? 2 negative things. In other words, it becomes the same charge. All right? The 2 objects become the same charge. The 2 objects become the same charge. All right? So when we do it by conduction or contact, the 2 objects will become the same charge. Yeah, always. Yeah, always. And so you're thinking already of the different possible combinations with pluses and minuses. And if we think it through, it will always be true because of this mathematical maneuver we do right here. We take the total, whatever it is, and we divide it right by 2, and they become the same charge of whatever it is. So let's see if we can think it through without drawing a million pictures. If this was +4 and 0, right, instead of worrying about the negatives, then electrons would move onto it, right, and make both of them positive because it sucks electrons away from the 1. And then I take the +4 and divide it by 2, I'm going to have +2 and +2. Okay?
If you had like a negative and a positive?
If I had a negative, oh, that's an interesting, we might end up with them, oh no, they'll still end up being the same. This is a good question. If I have a negative and a positive that are equal charge but opposite, what will the overall charge be after I touch them together? If they're equal and opposite, +2 and -2, what will they add up to with the total if I have +2 and -2? What will the total be? Yeah? 0 divided by 2. What's 0 divided by 2? Negative something? 0 divided by 2 is negative something? I'm mildly concerned about that calculation. It's 0, so then they both become 0. Okay? Let's say I had one that was plus 4 and negative 2. Plus 4 and negative 2. What's the overall charge when we add the plus 4 to the negative 2? Yep. Positive 2 divided by 2. And they're both going to be plus 1. They'll always be the same at the end. Always. You don't like it, but you can write down as many examples as you'd like, and you will always get that they're going to have the same charge at the end. Yep. Well, what you're doing is you're taking my simplistic picture of just 4 pluses, and you're imagining that someone's ripped off all the electrons, right? In the realm of there being billions and billions and billions and billions and billions of them, you won't rip all of them off. And if you do, what's happening is you're in a real high energy situation. And when I say high energy, I'm talking about energy near the surface of the sun, where all electrons are blown right off of everything. And you have a completely different state of matter at that point in time. So we're not even talking about metals anymore, or even solids, liquids, and gases. We're talking about a really high energy thing, which we can't really talk in terms of static electricity anymore. So that extreme, which does exist in our universe, is not something that we can talk about in this realm. Does that make sense? If we were to blow all the electrons off of a substance, we've really done something to it, and we're not talking about pith balls anymore. We're talking about something completely different. Okay? All right. Let's keep going. I'm almost done. I want to finish now off with our conduction. Did I call this 3? Am I calling it 3? Induction and grounding. And yes, Rachel, I see you. I'm not ignoring you. I'm going to write this down first. Induction and grounding. Induction and grounding. Are you going to tell me a story? Oh, okay. What do you got?
That's right on your prayer, but when you said up there's like 2 different people, and you said they will move to this thing. Can you be more specific?
You want me to be more specific on that example up top?
No, it said it will move to this thing. Plus thing.
Are you talking about my electrons here?
I'm talking about when I see certain like things.
Oh. Are you being like Jess right now?
What did I do?
Well, you didn't do anything, but I'm recording, so I can't call her what I called you because I'm making a recording. I believe Rachel's trying to be smart. What she's doing is she's trying to be smart. And when I say smart, I don't mean like high mark smart, I mean smart. Because when I was helping her at lunch, I wouldn't let her just say, move to that thing. I wanted her to be very specific, and I must have said that. And so now she's being smart. I'm going to continue. All right. Induction and grounding. I'm going to use spheres again. No, I'll use our charged rod. So yesterday we talked about induction and grounding. All right. There will be some review work in preparation for our quiz. It's on Google Classroom on the thing, so take a look at that. Preparation for quiz. I'm going to start in this case with a negatively charged object. In this case, I've got it drawn as a rod, like an ebonite rod or something like that. Doesn't matter how many negatives. I'm going to bring it close to the sphere, which we know we love 4 pluses. And trust me, I'm going to make you draw stuff like this tomorrow. Stick with 4 pluses. Don't go crazy with 5 or 6.
Yeah, Mr. Sanders.
This is a negative object, and I'm attempting to charge a neutral object. And now we've got to think about what the electrons do when I bring something close like that? What do the electrons do if I bring a negative thing close to this neutral object? It has its electrons in there. I just don't want to draw them yet because I've got to put them in the right place. Chloe, where am I putting them? The other side. I need more direction. The left side. Correct. The left. Correct. All right? Now, right here, we have a situation that I taught you at the beginning called induction. That's an induced charge separation. That's what that is. If I were to take the rod away, what would happen? What would happen? I didn't ground it. I just made that thing, and now I'm going to take the rod away. What would happen? What would happen? Rachel, what would happen? They'd go back to their positives, right? And if I brought it close, they'd go to the other side. If I bring it, take it away, they go back to their positives. So we call this induction. That's what that is. But now, let's ground it. This is now induction and grounding. What's going to happen here? Rachel? They're going to go away? Oh, no, you're right, actually. I'm being mean. Now I'm being smart. You're right. They're going to go away. They're going to go to where? What do we call it when they go away in this situation? Yeah, to ground. They're going to go to ground. All right? They're going to go to ground. Now we're going to cut the wire. We still need to have our guy nearby. We're going to cut the wire. Whoops, that's supposed to be a plus, not an asterisk. And I'm going to leave one more guy in here, but we've cut the wire. The wire to ground is gone. All right, you get the idea. All right. And in the end, look at what type of objects I have. I started with a negative and a neutral, and now I've got still the negative and a positive. All right, that's different than contact. Contact, I end up with two of them that are the same, but in induction and grounding, I always end up with two oppositely charged objects. All right? Okay, that's where I want to stop. I'm not going to do the opposite scenario because I just wanted to review it with you. Oh, I do want to put that little note at the end, that for induction, we end up with two opposite charges. All right, two opposite charges. Now, these are all important phenomenon. But like if you were studying electric phenomenon way back in the day, and we're talking about back in the day of Ben Franklin who flew a kite through a storm to discover that lightning was made up of static electricity. And these guys were studying the stuff that you studied, the basic laws of electrostatics. And that meant if they had a device that they could make charge, one charge, let's say they had only access to a positive charge, and they wanted to make something else positive, what did they have to do with it? Let's say they had a sphere and they had a rod or something that has a positive charge. If they wanted a second positive charge, maybe to study repulsion, what did they have to do with these two objects to make both of them positive? What did they have to do with the two objects? You got three options. You could rub them together, you could touch them together, or you could do the induction and grounding maneuver. I've got a positive and a neutral, and I want two positives. What do I have to do with these two things? What do I have to do with them? Jamie? If I make a positive repel and ground it through induction, I end up with two opposite charges. That's not going to get me the two charges that are the same. So I can't use induction and grounding. That would give me two opposites. And if I wanted two opposites, that's what I would do. But I want two that are the same. What am I going to do? What am I going to do? Yeah, Chloe? I'm going to touch them. Conduction. I'm going to touch them together. Two the same. If I wanted opposite, I'd bring one close. I'd touch it. I'd take the touch away. I'd bring it away. And I would induce the opposite charge. Okay? So that allows you to get any charge you want, if you start with whatever charge you want. Okay? Those two methods. All right, I am going to stop my recording at this point. If I could see my cursor. Come on, cursor. Come on, cursor.